Today we're going to talk about the install, setup, and configuration of Slingshot, which is included in the Red Team Toolkit. Slingshot is a Stage 2 remote access Trojan that is used by high-functioning Red Teams to covertly further their access within a target environment. It is designed to be extensible and stealthy, allowing operators to covertly access resources within the target environment. Slingshot is composed of two main pieces, the Slingshot agent and the Slingshot LP. Slingshot agent runs in memory on the target. It is written in C++ and calls back via HTTP or HTTPS requests to the Slingshot LP. Slingshot LP is written in Python and acts as an HTTP server that one or more Slingshot agents can connect to for command and control. As a customer of RTT, the source code to Slingshot LP will be available. Slingshot agents will be binary patched based on your specific configuration and profile specifications, which we'll talk about shortly. Also, as a customer of RTT, you will be given access to the Red Team Toolkit portal. Once logged into the portal, you'll have access to detailed documentation on tool usage and functionality, Slingshot scripting and APIs, and the setup and configuration of Slingshot. Now let's quickly go through the setup and configuration of Slingshot. In this example, we'll use a standard Linux Kali build. We've simplified the installation process down to just a few easy steps as documented in the RTT portal. Slingshot LP is written in Python 3, so be sure it is installed before proceeding. After installing Python 3, it's as easy as downloading and running the RTT Python script. The RTT Python scripts installs all the dependencies required to run the Slingshot LP and then downloads the Slingshot LP to the host. Now you'll notice after running the RTT script and downloading Slingshot, there's a Slingshot folder in the directory you executed the RTT install script from. Let's review some of the key files and folders in the Slingshot install directory. First, note slingshot.py. This is the file to run with Python 3 to start the Slingshot LP. Second, note the data and lib directories. The lib folder contains the source code for Slingshot LP. Modifications to files within the lib folder shouldn't be necessary. The data folder contains user-specific logs, scripts, and files. Within the data folder, there is a downloads folder. This is where files downloaded from the target get stored. There's also an HTML folder. This folder acts as the web root directory used by the Slingshot LP to host legitimate HTML content. Obviously, this will improve the OPSEC of your operations. The logs folder contains target log data from the Slingshot sessions. The payloads folder is where the binary patched Slingshot agent payloads get stored. The PowerShell folder is where PowerShell scripts are stored for use in operations. Save all PowerShell scripts for use in operations in this folder. The scripts folder is where Slingshot scripts are stored. Save all Slingshot scripts in this folder. Now let's go ahead and fire up the Slingshot LP for first-time use. The first time you run it, Slingshot notes that a C2 profile has not yet been created. A Slingshot profile defines all the malleable aspects of the Slingshot agent. For first-time use, you can customize or accept the default settings. These C2 profile settings are stored in a config.json file. If modifications are later desired, simply modify the config.json file that gets auto-generated in the Slingshot directory on initial use. Also note that Slingshot will generate self-signed SSL certificates. These are the PEM files located in the Slingshot directory. You'll want to replace them with legitimate SSL certificates prior to conducting operations if you plan to use HTTPS callbacks. Now let's go ahead and take a look at the config.json file that was just generated before generating our Slingshot payloads. We have made Slingshot flexible so you can customize the binary patching signatures to your liking. Within the config.json file, everything from post variables to get variables to SMB named pipes to encryption keys are all customizable. Simply modify the setting you'd like to change within the config.json file. Again, anytime the config.json file is modified, you'll need to regenerate your Slingshot payloads to patch the changes into an updated agent. After building our initial profile, Slingshot notifies us that our payloads folder is empty. That is because we have not yet binary patched the agent based on the C2 profile we just created. This is performed using the generate command within Slingshot. You'll notice upon running generate, Slingshot gets binary patched with the C2 profile you just created, and the payloads folder is now populated with the appropriate Slingshot binaries. We're now ready to deploy and use Slingshot. Now there are a few ways to deploy and use Slingshot. The first is as a DLL. This file can be used for DLL injection or reflective DLL injection. The Slingshot DLL is stored in the payloads folder. The second is shellcode. This file can be used for shellcode injection. The shellcode binary is also located in the payloads folder. The last is a PowerShell web deploy. This technique can be used to get access via PowerShell one-liner. To generate the one-liner, simply use the deploy command within Slingshot. Note that being a Stage 2 tool, Slingshot is designed to run in memory. We do not recommend copying and running non-stager binaries directly to a target. For the sake of the demo, we'll quickly deploy Slingshot through a PowerShell one-liner. The deploy command has a few options that increase stealth, but in this case, we're just going to use the defaults. As you can see, executing the PowerShell one-liner on a remote target provides us with a Slingshot shell. We're now ready to conduct interactive operations. Stay tuned as we provide additional videos on the usage of Slingshot and the Red Team Toolkit.